Hello. 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 Hey, Cody.
Yo.
How's it going? Okay, we got a mic here. Let me go see if I can find Rachel. I love you. I love you. Hey y'all, we're waiting for Rachel to show up. We're a little bit early, so I'm not super. Hopefully that works. Cool. Stratum V2. I don't actually know much about Stratum V2. Like, find things out.
Hello.
Hey, Rachel, how's it going?
Good, how are you?
Great, cool. Thanks for joining us. We're super excited to have you.
I'm excited to be here.
I was just saying, I was like, I don't think I know like any, I don't think I know much about Stratum V2. So excited to hear whatever you have to tell us about. We're like a little bit early, but I'm okay starting if you want to go ahead and go for it. I think it's recording and double check. Yeah, so we're recording it and we'll put it up later, and we tend to just kind of get started early.
Okay, cool. Yeah, I have a lot to go through, so.
Great. Do you want me to do like a quick intro, or do you want to intro yourself?
You can do the intro.
Great. Hey everyone, welcome to Base58 Encoding, our Friday summer series of deep dives into cool Bitcoin open source projects and protocols. Today we've got Rachel Rybarczyk from Galaxy Digital, who's going to be giving us a deep dive tour into the work she's been doing on Stratum V2. For those of you who are like pretty out of the loop on mining stuff like me, my understanding is that Stratum V2 is a way that pools talk to the pool coordinator, so to speak, or I don't know what the official term is. But Rachel's going to show us, like, I guess, like how it works and what work she's been doing on it. So
yeah, so I have like a presentation I gave at BitDevs last week. So I was going to go over the first part because the presentation was for demoing what's called like the template provider, but that's not what I'm going to be showing today. But the first part kind of gives a really good introduction. So let me, oh, can I share my screen? It says host disabled participant screen sharing.
What about now? Does that work now?
Yeah.
Great. Okay.
Okay. Let me move this little Zoom window out of my way. And okay, so a mining protocol defines the communication between the mine devices and the mining pool to contribute hash rate to the network and confirm blocks on chain. So it's just like a set of rules for communication between these entities. So like this is Stratum V1. This is the messages that are sent. So we have the mining farm on the left with all the miners and then the pool server on the right. And the messages, there's a few more messages in this, but these are the core messages and they're all sent in JSON RPC format. So they're human readable, they're very verbose. You notice here, you actually send your username and password to the pool unencrypted. So that leaves you open to like a bunch of man-in-the-middle attacks. And then this is what an overview of the Stratum V1 connection would look like. So you just have your miners, direct connection to the pool, and then the pool is connected to a Bitcoin node. The pool selects the transactions to be confirmed or to be included in the candidate blocks from their Bitcoin node, which is connected to the peer-to-peer network. So a lot of miners use a proxy in Stratum V1, even though it is non-standard. So the proxy is not specified in the protocol. The Stratum V1 protocol was made roughly 10 years ago by a Bitcoin Talk user named Slush. And it was really beneficial at the time, but the way the industry has grown, it's really lacking in a lot of areas. And so you see a lot of non-standard proxy implementations to aggregate connections implemented by the mining farms themselves. So this is just an overview of the main inefficiencies of Stratum V1. Like you mentioned, it's non-standard, it's inflexible and not very well specified. JSON RPC messaging format, so it takes a lot of time to serialize and deserialize those messages into a machine readable format that the ASIC can read. Unencrypted connection. There's also an unauthenticated pool connection, so that leads to another variation of the man-in-the-middle attack where the attacker could pretend to be a pool and intercept your shares. And it's also prone to transaction censorship because the pool is the party that's selecting all the transactions to be confirmed on chain. So Stratum V2, we just got a logo, which is very exciting, very official. Here's an overview of Stratum V2, why we like it. So it's standardized, it's flexible. We have ways to add extensions that are very specified by the protocol. It's a complete protocol. So the library, the Stratum library is a set of primitives that can be used by a miner if they want to write their own firmware. It can be used by a mining farm to write their proxy, and it can be used by a Stratum V2 pool to implement their pool server. It's got a concise binary messaging format, so we got rid of JSON RPC. It's got an encrypted connection between the miner and the pool, and then it also authenticates the pool connection. So that gets rid of those man-in-the-middle attacks. And it has the option for a democratized block template. So it leaves it up to the miner to choose their own transactions. The miner doesn't have to choose their own transactions, but they can, which is a really good feature for network security. Okay, so with all those benefits comes a lot of complexity. There's a lot of different ways you can configure Stratum V2 to mine. So here is sort of the most primitive way to use Stratum V2. It's very similar to what we saw with the Stratum V1. We have a direct connection to the pool for each miner. This is called header-only mining, where specifically there's no Coinbase manipulation by the miners. So that's all done by the pool server. So there's very little work to do on the miner's end. And then here the pool server is selecting the unconfirmed transactions. This requires a modification to Bitcoin to include something called a template provider, which is logic to go and select transactions from the mempool and store them to be sent to the pool. And honestly, so in practice, you would never really want to do this configuration. You would always want to use a proxy. which would look like this. So the beauty of the proxy, well, actually this in practice is what you don't want to use. This is actually similar to what Slush Pool or Brains is using right now. They have Stratum V2 firmware that they're running with standard channels directly to their pool. And they get a lot of efficiencies with the binary messaging format, but they don't realize the full efficiency gains of the Stratum V2 protocol without that proxy server. So if we naively implement the proxy server, it would basically just sit in between the mining devices and the pool and just forward those messages to the pool and back. So this is the one where you would never implement in practice. You can, but there's no real reason to. What you would want to do with the proxy is use this group channel. So this group channel aggregates the connections of the standard channel and aggregates a lot of the data, and it creates a big efficiency gain and less bandwidth is used. So okay, so here is a configuration if a miner wants to select their own transaction. So in this scenario, a miner would need to run their own Bitcoin server with the template provider logic in there. And it would use what's called a job distribution protocol to get the messages from there. And then it would use a job negotiation to communicate with the pool server to make sure that the transactions that were found on the miner side is acceptable to the pool. Okay, this is what we're going to focus on today. I've been working on writing a Stratum V1 to Stratum V2 translation proxy. So my hope is that it can be used for mining farms that still have the Stratum V1 firmware running, but they want to gain a little bit of efficiency, and specifically they want to gain that encryption from Stratum V2. So we still have the Stratum V1 connection between the mining device and the proxy, but then we translate the messages into Stratum V2 and we send them to the pool over what's called an extended channel. So there's 3 channel types: standard, group, and extended. Okay, so let's get started. Does that all make sense to everybody?
Yeah, I got a couple questions.
Yeah.
So just for clarifying, right? So on the pool side, they're like currently, if you don't have the template provider, they're selecting the transactions, making the template, and they're just providing the header for the hashing to the mining farm right now, right?
So we're looking at this one.
Yeah.
The pool runs the Bitcoin node, and between the standard channel, there's no like Coinbase manipulation. So this is the header only mining, but you can choose to have the proxy do that Coinbase manipulation for you and choose those extra variables for you.
Okay. And when you say Coinbase manipulation, that's that like outside of just like the allocated node space in the header, it's you can also tweak like stuff within the Coinbase transaction, stuff within the message section and that sort of thing in order to get like basically additional node space.
Exactly. Yeah.
Okay. Gotcha. And so like kind of like one of the advantages, right, is of like doing this pooled model is that there's no like repeated hashing attempt, because like each pool has their own template that they pass, and like all of the different miners are trying the different nonces. If the mining farm does its own template, then wouldn't you get repeated hashing attempts between the different mining farms that are trying the different templates?
I mean, if 2 different mining farms select the exact same transactions from the mempool, yeah, but it wouldn't really affect one mining farm or the other, right?
Okay.
It's just whatever mining farm gets that nonce first for that same set of transactions. I don't know the likelihood of that happening though.
Okay.
Any more questions?
If they're selecting their own transactions within there, are they still using like the allocated nonce sort of space that the pool tells them to, or is it like basically they're just using at that point they're just kind of using their own thing?
They can use their own configuration as long as the pool agrees to that configuration ahead of time.
Okay. Okay. Gotcha. Thanks.
All right. Okay. So so I've been working on this translator. It's not done yet. We're not going to finish it today. There's a lot to it. But we're gonna use a lot of like asynchronous programming, and we're gonna send messages between different channels, and we're going to get a little bit of an overview of both Stratum V1 and Stratum V2. And so where I'm at with this right now, actually first let me show you this. So this is a forked Bitcoin node with that template provider logic in there. So I have this running in the background on RegTest, and I just instantiated it with 100 blocks, and it's just going. This is needed for our pool logic. So we have a lot of roles that are implemented. So like the purpose of the Stratum library is to, like I said, provide a bunch of primitives for people to choose from to create their application. And so there are a few applications in here that are made using the library. So there's a dummy Stratum V2 pool. There is a Stratum V2 mining proxy and a Stratum V2 mining device. For the purposes of this project, I created a Stratum V1 mining device to send messages to our translator. And then we will be using the Stratum V2 pool application. So we start the pool. The reason why this works is because we have that Bitcoin node running, and then we start our translator. Okay, we get some messages here, which we'll get into. And then we start the Stratum V1 mining device, and we have some more messages here that are sending back and forth. So this is as far as we will be able to go today, if we even make it this far. But that is the goal, to walk you guys through all that. All right. Okay, so I set up a translator proxy example for us. I have, let's look at main. So we have our upstream logic. So this is going to receive messages from the pool and forward them to the proxy. And then we have our downstream logic, which will receive messages from the miner, the Stratum V1 miner, and forward them to our proxy. Also, the messages between Stratum V1 and Stratum V2, they're not one-to-one. So it's not going to be as easy as just passing the messages through. So we have to have logic in there that says, okay, like, is this a message from Stratum V1? Does it have any information that Stratum V2 needs, and vice versa? So this is going to be our main function. This is the address we're going to listen on for our mining device. And then we're going to instantiate our translator. So just to look here. So I'm not going to read all this, but basically, the Zoom thing is hiding my screen. It's very annoying. There we go. So the translator sits between the downstream role and the upstream, and it accepts messages between the two and translate them into the appropriate protocol. What we're gonna do with the translator, first we're gonna connect to the upstream. We're gonna send a setup connection message to the upstream. That's a Stratum V2 message. And we're gonna get a hopefully setup connection success message back from the pool. If that was successful, we'll get an open extended mining channel. We'll send that to the pool, and then we will receive the success back. And then we will expect to get a set new prev hash message and set new extended mining job message. So these are the messages we really care about. This is just like, okay, like we're connecting to the pool. The set new prev hash message, that is going to contain the latest prev hash, like the most recent prev hash on the chain confirmed. So like the previous block header hash. And then the new extended mining job has everything else we need. So let's look at the spec. Okay, so the new extended mining job, server provides an updated mining job to the client through, oops, down here, sorry, through a channel. So we're gonna use the extended channel. Where are we? Here we go. This is what's gonna be in there. We're gonna have a channel ID to just identify the channel. We're gonna have a job ID. So that's the server's identification of the mining job. The future job. So we're not gonna get into this, but basically in Stratum V2, the server, in this case, the pool server, has the ability to cache potential candidate blocks. So potential new templates. And this Boolean says, okay, if this is true, we're going to cache this message. But if it's false, we're going to start mining on this message. Version, if we're going to do version rolling, the Merkle path, and then the Coinbase prefix and the suffix and the extra nonce will be sandwiched in between. So that's what the new extended mining, let's set new prep hash 2. So that's down here. There we go. So distributed whenever a new block is detected in the network by an upstream node. So again, channel ID, job ID, here's the prep hash, the end time, and the end bits. And all right, so while we're going to listen for, after we do this messages, at the same time, we're listening for downstream miners to connect to our proxy. On connection, this is actually wrong. We're going to get a mining.configure first. And then we send back a response to the mining.configure, and then we get a mining.subscribe. And so let's look at Stratum V1 real quick. So this documentation actually doesn't have the configure message, but that's okay. So the miner.describe has the set the miner asks for a mining.subscribe, and then the server needs to respond with the difficulty, and then a mining.notify with the previous block hash in there, and then the extra nonces. So this is going to get tricky. I haven't got to this part yet in the translator, but it's like the next thing that needs to be done. And so Stratum V2 sends the prep hash and the rest of the block template in 2 different messages. So when we get to the point where we need to respond to this mining.subscribe, we need to have some saved state of those other Stratum V2 messages and save both of them. We'll first wait for both of them to arrive and then save them, and then use those 2 messages to create this response. So, just keep that in mind. And then we have this mining.authorize in here. And here is a mining.notify. So sorry, I have a puppy and he's squeaking his toy. I don't know if you guys can hear that. But so the miner, when a miner finds a share, they'll set a mining.submit. Okay, right here with their username, password, all their solutions, right? And then they expect like a mining.notify in response for the next job. So that's kind of a poor overview of Stratum V1 right there, and the messages we're going to be dealing with. But most of this, yeah.
Yeah, so for that difficulty, it's not like the actual difficulty for the block. It's that for each miner, they have like a slightly higher difficulty, and they're submitting all the blocks that meet that slightly higher difficulty as like the proof that they're actually mining and they're trying, right? Even if
that's exactly right. Yeah, right? Yeah. And right now, I just have that hard coded. A lot of things are hard coded right now. Okay, so contrary to this documentation, we get a mining.configure first, and then we'll get a mining.submit, which then we need to format into a submit shares extended, which is not done yet. And then, just like I said, when a new block is confirmed on chain, even if the miner isn't done mining on their block, we don't want to keep mining on stale shares. So we need to make sure that we're listening for a set new prep hash, which will be followed by a new extended mining job. So that's the overview. And then now let's get to the translator. Okay, so we need to have 4 channels for this translator. We need to have a channel so the downstream can send Stratum V1 messages to the upstream translator. And then we need to have, so that would be the downstream sender. And then we need a receiver for that message on the translator. So it's going to be something like let sender for downstream, receiver downstream for proxy, and we want to, we're sending Stratum V1 messages here. Let me import. We're going to use async std, and we're going to do sender, receiver, and bounded. I've already imported all of the dependencies that we need. Let's actually look at the dependencies real quick. That's fascinating. So we're using async std, async channel to handle all of our task spawning and channel communication. Codec SV2, that is going to have a lot of the message framing formats that we need for Stratum V2. Network helpers, that's something to do with just how we're going to connect to the network or to the upstream, Stratum V2 upstream. We don't really pay attention to that too much. I forget what this one is. This is going to have like all of our important roles. So like our like minor roles and our pool roles and like how we interface with those things. Saturday JSON. I don't think we're using Tokyo anywhere, so I could probably remove that. And I just hard coded the config stuff, so not TOML. And then V1 is where we're going to have all of the messages and things that we need to interact with the Stratum V1 miner. So that's the packages we're working with. Okay, so we want to send and receive a JSON message, Stratum V1 JSON RPC message between the downstream and the use V1 and the translator. Use that message, JSON RPC message equals bounded. It's just like a bounded channel, randomly selected 10. Let's do this. And then this needs to be, let me do, so you can see the errors that I'm seeing. Okay, so I imported this wrong. So this needs to be async channel. Make sure I don't have this running anywhere else. Okay. Okay, well, we need to implement, what's wrong with this? Oh, I need to make it a tuple. Sender, receiver. There we go. Okay, and then we need to have a channel for the translator to send to the downstream and for the downstream to receive from the translator. So we're going to do the same thing. We're going to have sender downstream for proxy, and then receiver for downstream. Okay. And actually, let's take a look at the JSON message real quick so we can all see what that is. I think it's an enum. Okay, so we're going to expect a JSON message. It's going to be a standard request, a notification, an OK response, or an error response. And so the standard request looks like just the ID, method, and then the values. So we just saw that on that brains documentation. And then the notification, very similar. So it's just your basic JSON RPC messages. So that's what we're expecting. Okay, and now we need a channel for the upstream to send to the translator and for the translator to receive from the upstream. So we're going to do the same thing, define these channels. So let sender for upstream and receiver upstream for proxy. And that's going to be sender, and we're going to use something called either frame, which we'll talk about in a second. Receiver frame founded. And then the compiler is going to complain because I haven't implemented that yet, but let's do our last channel. And so then we need a channel for the translator to send to the upstream, for the upstream to send back to the translator. We have 8 channels total. We just defined 4. So sender, upstream for proxy, and then receiver for upstream. Okay, so let's store these, store the relevant channel ends in our translator struct. So sender to downstream, sender JSON RPC message, and then receiver for down or from downstream. And then we need to send the messages to the upstream. So sender to upstream. And then receiver from upstream. So that's what it's going to look like. And then we can just create a new translator struct here.
Rachel, this might be kind of silly because I'm not really a Rust person, but what's the pub crate thing? Is that a weird question to ask?
No, not at all. That is just, it's like halfway between public and private, where it's like the crate logic can call it, but like externally, you can't call it. Is this pace good for you guys? I'm not boring you guys. You like the live coding?
Yeah, it's great. I mean,
Okay.
I'm having a good time. I've been kind of translating what you're doing into the notes, so people who have like, you know, just another thing to follow along. But yeah.
Yeah.
Oh, I was gonna. Okay, sorry. Yeah, it's like, so the crate is kind of like a package level visibility, sort of.
Yeah. So like with this project, we'll be able to see how to use a library and things in the library, because I feel like it's hard to just dive into one aspect of the library because there's like so much going on. And so with the Stratum V1 and Stratum V2 translator, you can actually like see like how these messages are used and like why they're there.
Cool.
Yeah, but if you guys want me to like speed it up at any point, let me know. I can. And then I have a lot of this already done in like a separate branch with a ton of comments too. So
no, this is awesome. This is awesome. Yeah. Keep
okay.
going. Yeah.
So then we want to, so this is going to be the sender upstream for proxy. This is going to be the receiver upstream for proxy. And this is going to be the sender downstream for proxy and receiver downstream for proxy. I made these like really explicitly named because when I was first coding this, I was getting like so confused with all the channels, and I was like, I passed in the wrong one, and it was a lot. Okay, so we have our translator here. Exciting. Let's go into what either frame is. So let's go into our upstream, and I have these already coded here. So before we get to either frame, let's start with pool messages. So let's do, where are our pool messages defined? Oh, and I'm actually gonna have to go up a couple. There we go. Did I spell that wrong? Oh, it's an enum. Okay, so let's go to parsers. We want to implement that. So use, that's in our roles, logic, parsers, pool messages. It's on line 963. Okay, so this is for the Stratum V2 side. So we have a struct of all these different messages we can have. We can just have like some regular messages. This is going to be like the setup connection stuff. And if you want to change your channel endpoint, we have our mining messages. So that's going to be like the set new prep ash, the new extended mining job, the submit your shares, things like that. And then job negotiation and template distribution, we're not going to get into, but that is for job negotiations for when the mining farm wants to negotiate a job that they've created using their own unconfirmed transactions on their own Bitcoin node with the pool. And then template distribution is distributing the template. So that's what pool messages is. So we just like make this easy for us to call. And then let's look at standard SV2 frame. So that's just going to be, instead of like the JSON RPC that we're using, it's just like a frame to hold our messages. Standard. There we go. All right, so we want to import that. That's in codec. Standard SV2 frame, and then standard frame. So here's where these are defined. So we had in the upstream. So this is just going to hold like a regular Stratum V2 frame. Let's look at what Stratum V2 frame is. It's a struct. It has our message header, what our message contains, and I guess the serialized value of both of those. So that's just how, like, the message format that we're passing over the wire. And then standard either frame is probably very similar. Let's see. Oh, it's right here. Yeah. So, oh, this is going to be if it's like a noise. There. So, or if it's a handshake or an SP2 message. So if we're doing like a handshake initialization. There we go. Thanks, Lisa.
Okay, he's gone.
So it can be any one of these things. And that is how we're going to pass messages, or what's going to contain our messages. Let's see, what do we want to do next? Let's try to connect to our upstream in our translator. So let me look at one thing. Okay, so to connect to the upstream, we're going to do let upstream adder. We're going to use socket adder from just from regular standard library. Oh, What was our error over here? Let me try to fix that real quick. Pool messages. Oh, whoops. We're gonna call this STD frame. There we go. New IP adder from just localhost. And then we're going to listen on 34254. So this is where we're listening for the upstream pool, and then let upstream, let's create a new upstream, which we have not implemented yet, but we're going to need the upstream adder. We're going to need, I actually already hard coded the upstream or the upstream connection. Maybe not. Oh no, here it is. I was like, I thought I. So we'll get into what this is in a second, but it just has to do with the handshake. And so authority, public key, sender for upstream. So that way the upstream can send the translator messages, and then receiver for downstream, or receiver for upstream, sorry. Okay, and this is going to complain because we have not, we need to do implement from stir, I'm pretty sure. Yeah. So let's use create upstream SV2 upstream, and then we need to actually implement it. Okay, so there's gonna be a lot of code that goes here because again, there's a lot of complexity with Stratum V2 because it is a all-encompassing protocol with so many variants. So the first thing we want to do is give ourselves some types to work with. We are going to basically, there's going to be, for the purposes of this demo, there's going to be one member field of upstream that we work with, but I'm going to define a second one that won't be used, but it's just needed to be present to get this working. So our connection, this is just going to hold our channels that we've defined. And then we have a downstream selector. This would be like how we select our downstream like minors. But there's like a lot of logic that has to do with that. So we are just making a lot of assumptions and doing some hard coding, but just for the purposes of implementing some traits, we need that here. So this is going to be downstream mining selector, and then it's going to take our downstream, which we need to implement, create, use, create, downstream. And there's going to be a lot of complaints here. First, let me find where the, that's gonna be a trait. No. Okay, so it's in selectors. Okay, a downstream mining selector is useful for routing messages in the mining proxy. This mining proxy it's referring to is for Stratum V2 though, so we don't really use that routing logic, but it still needs to be present. So that's what that's for. And then it takes the downstream, which is our Stratum V1 downstream. And so we need to implement that. So
Really
we
quick
wanna-
question, Rachel.
Yeah.
So like, just like with the selector, is this because there's like lots of downstreams and one upstream? So the upstream kind of needs to know which of the downstreams it's talking about, or is this like solving a different problem?
Let's read in the code.
Okay.
Selectors are used from the routing logic in order to choose which remote or set of remotes a message should be relayed to, or which remote or set of remotes a message should be sent.
Okay, yeah.
So exactly what you said.
Oh,
Yeah.
great. Okay, cool. Oh, that's super cool. Yeah, it's like, okay, cool. Yeah.
Okay. So we have that. So, okay, let's get the connection done because that's gonna be quick and we'll now have all our upstream connectors. So here, again, this is gonna handle the sending and receiving to and from the upstream pool and to and from the translator. So we are gonna have a receiver, either frame. I also just love how Rust like automatically imports that. I don't know if you guys saw that, but that was really incredible. So this receives from the upstream, like basically our SV2 pool server. And then we're gonna need a sender for that too. Sender. I like to have the receiver a second. And then we need the communication with the translator. So we're gonna have a send to translator receiver upstream. So it's gonna be create sender downstream because the translator is downstream from our upstream logic. The frame, and then same thing here. Okay, we got that. And then here is what we're gonna send our messages to the upstream wall, which we'll implement in a little bit. Gotta get a comma there. Let's see what's going on down here. Oh, I need to import the use async channel, sender, receiver. That should be it. And then we need to import our proxy downstream binding selector. So use our roles SV2 logic, and that is in selectors and then proxy downstream binding selector. So now things should be okay. So now it's saying like, hey, I see that we have this selector and it's expecting this downstream, but downstream isn't implementing is downstream. So it's confused how to read this. A requirement for this is that we must implement a trait called is downstream. So let's implement is downstream on the downstream. First, we should probably initialize the downstream. So let's really same kind of thing here. We are gonna have a connection downstream connection. Use create downstream connection. And then let me make this easy for us. And I will just open up my downstream connection from okay, here's our channels right here. So we have a channel, well, they're not complete channels because well, this is a complete channel. So this channel right here is what's going to communicate with the Stratum V1 mining client, sender outgoing and sender receiving. So outgoing, we're going to send, receiving, we're going to receive from the client. And then this is going to send to the translator, and this is going to receive from the translator. And then let's include that. So we have that there. And then we don't need to look at this file again. Okay, so let's implement is downstream, or is is downstream, which is right here. And then let's find where this is and see what it does. There's not much to it, and okay, so it's in, we want to do use roles, logic SV2, selectors again, and oh, sorry, not selectors, common properties, and is downstream. Now we can treat, there it is. So this is all it is. General properties that every SV2 compatible mining downstream node must implement. Obviously we're using a Stratum V1 miner, but our upstream is Stratum V2 and it needs this trait to work. So we just use it. And then let's see what else we're complaining about. Let's go back to our translator. Stream. I don't know why that's not implementing or importing. Should be use create upstream SV2. It's weird. Similar notice capitalization. Let me do that. Yeah. Okay, so I need to make it so we can use it upstream. Upstream connection. Hopefully that fixed that. Okay, so now we need to get either frame, which is defined in our translator. And then we need to import upstream connection in our upstream. There we go. Sender to, oh, I messed these up. Sender to downstream. There we go. Okay, so now let's fix this complaint, because in our translator, we are declaring this new upstream, but we haven't implemented our upstream yet. So let's do that. We expect an address, which is going to be a socket adder. Let me just grab this. And then we are going to pass in that authority public key, which is a array of 32 U8s, and our sender downstream, which is a sender either frame, and our receiver downstream, which again, which is a receiver either frame. Great. And it's going to return the result. It's going to be an arc mutex of self. But for now, I'm just going to comment that out so we can get things compiling. Okay. So the first thing we want to do is we want to connect to the SV2 upstream role, right? So we're going to do let socket equals TCP stream, which we need from the, where do we need that from? The async. So use async and then TCP stream. And then we want to connect to it, give it our address, await, and then just like map error. Zero error handling is happening in this demo. Let's see, oh, we need to import either frame. Great. Oh, and we need to import the sender and receiver. We're not using bounded. Are we using? I don't think we need bounded in this. And, oh, I need to do that. Cool. We're compiling. Very exciting. So we've connected to the pool on the most basic level. And then let's initiate the connection. So we have the initiator, and that is going to be initiator from raw k, authority public key, unwrap. And let's look at where's initiator at? So initiator is in the codec, so we're going to use codec SV2 initiator, and I'm just going to throw in, we're going to need the handshake role, and we're also going to need a frame. So let's go down to look and see what the initiator does right here. So this is doing that like handshake connector, handshake protocol with the pool. I'm not like super familiar with it, but that's what's happening here, and that's why we need that authority public key. So that's like the authentication to the pool that Stratum V1 doesn't have. Okay. Now let's just print line upstream connected. And we need to do our channels. So channel to send and receive messages to the SV2 upstream role, our pool server. So we're going to do let receiver sender equals connection new, and we're going to give it our socket and the initiator, the handshake role initiator that we defined. I think the 10 is for the bounded channels. Basically, this connection does all of that like channel setup for us. So I think the 10 is specifying 10 bounded channels. And then connection comes from, I think it's an actually just like setup connection, I bet. Maybe not. Let's find it. Oh, it's in network helpers. So use network helpers connection, and then we can go down to the connection and we can find it and see what it does. There it is. So, okay, it just holds some state. It's gonna be like the state of the handshake, I think. So let's, it's probably medium. There it is. Okay. Yep. So this is our connection state, not yet initialized, or are we doing the handshake, or I don't really know what the transport is. Transport mode where AE, AD is fully operational. So you can Yeah, I'm not like super good with the initiation stuff yet, so I don't want to like talk too much to it because I don't know. Let's go back to our upstream. So that's going, and then let's define our upstream connection. So let's look. We're gonna have our sender, our receiver, our sender downstream, which is going to just be the sender downstream, and receiver downstream. And you know what we just called this, that. Okay, so we have our connection there. And then we are going to set up the connection we're going to create our upstream self by calling setup connections. We're going to do let self equals self setup, setup connection. And we are going to pass in our connection struct, and it's going to be asynchronous. So we're going to wait on that and just unwrap it. All right, 1 second.
You've got a spelling error. You're missing an I on upstream connect on line 7, or I guess like, yeah.
Oh, thank you.
Yeah, no worries.
Connect, is that right? Great. Okay, so do we need to pass in? No, we don't pass in self. Now we're really gonna start getting into it. So we pass in our connection, which is upstream connection. And then the result is going to be an arc mutex of self, and then just a unit for the error. But just, yeah, whatever. So we need to get the setup connection message. We need to construct our setup connection message. So real quick, let's look at this spec. And see what's going on there. So we have some flags to tell us if we're doing like version rolling, or if like who's selecting the work. I want to see the actual, let's look at the protocol overview. Here we go.
Rachel, where is the protocol posted? Where, like online? Is this something we can look at? Oh, dope. Okay.
So it's at github.com Stratum mining SV2 spec.
Cool. Okay. I'll
Yeah.
post the link in the chat too. Thanks.
Perfect. Yeah, I'm like constantly referring to this. So the set connection, it's going to say, okay, like what kind of protocol are we using? We're just going to be using the mining protocol. We're not doing any of this. The minimum version, this is just for different versions of Stratum in the future. Flags, which we just kind of looked at with the version rolling stuff, our host endpoint and port, and then our device information. And yeah, and so we need to create that message. So let setup connection equals self get setup connection message. So we're right here. So we want to return a setup connection. There we go. And then that should be in setup connection, I believe. Okay, so that is that's in the common messages. Have I imported that yet? Nope. So use common. Oh no, sorry, that's in roles. So we're gonna implement a lot of things from roles. So we're just gonna common messages SV2. We are going to use the protocol eventually, so I'll throw it in there. and the setup connection. And now let's look at that struct and see what we need to do for it. Is this the same one? No. This one is the one we want. And then let's go back to our upstream. Okay, so exactly what we just looked at. To make things easier, I am just gonna copy this over from the implementation I already have. Right here. So we just hard code everything right now. Okay. That's fine, we'll get to that error later. What else is going on down here? Oh, we need to import our mutex. So FI3, he's like the main developer on Stratum. Like everything I learned about Stratum V2, I learned from him. And everything I know about channels, I learned from him. But he created a like custom mutex that we use. So I need to import that. Great. So let's go back here. So that's good. We have our get setup connection message. Have it here. And now we can, where am I?
Rachel, I'm offended. You're not gonna like make Base58 a vendor of this machine or whatever. No, I'm kidding.
Next time I'll hard code Base58 instead of Bitmain. Honestly, I probably could right now, but like just in case it messes everything up, I don't want to touch it. Okay, so then now we want to put that setup connection message into a standard frame, which remember our standard frame is defined as just a standard SV2 with a pool message enum. So what that's gonna look like, we're gonna do let SV2 frame and standard frame, and that's gonna be pool messages. Need to import that, which is in parsers. Parsers, pool messages. And then the variant I want is common because we're doing the setup and the common handles the setup connection stuff. So we pass in our setup connection message in there, just give it an into to convert it to whatever type it wants. Try into to get it into that standard frame and then unwrap that. Okay, so we have our standard frame. Now we need to wait for the SV2 upstream to respond with a setup connection success or error. So we're gonna do let mute incoming. It's gonna be standard frame connection. So we're gonna use that some of our connection channels here. Dot receiver dot receive dot await dot unwrap dot try into to get into the standard frame dot unwrap. Okay. So we haven't received anything yet, obviously, but that is waiting for the response.
Rachel,
Okay.
Sorry, weird question. Where do you send so like, okay, so you get the setup connection message, right? Which just builds the message that you're gonna send, right? So you build the message and you've got that in the setup connection, and then you put it into this like standard frame object. Where do you send it over the wire?
We send it in another, let's see, where's my sender dot send? We're gonna get to it.
Yeah.
Is it in the translator?
I guess like, because like, so you build it and then it looks like you wait for the connection success thing, but if we didn't send it, I don't know, maybe it's a weird question.
It's not, no, it's not a weird question at all. Maybe, I mean, we're gonna get to it, I think. Or maybe when, let's get through this function and see if we hit that. And if not, I'll look around for it, but it is somewhere. Okay, so, oh, I missed a line. Thank you, Lisa. It is right here. We do connection.send, and we do SV2 frame, await, and then map error. Do that. So we need to implement send on our upstream connection. Thank you so much. Okay, so let's just do a print line and we can say upstream send, and then we are going to print out the SV2 frame we are sending. And then we're gonna do let either frame equals the SV2 frame dot into, because we've defined our sender and receiver to be either frame. And we're gonna match on self.sender dot send either frame dot await. And then this is all we need to do. It just, we don't need to pass anything back besides if it was okay or if there was some weird error. So that's where this is, the sending to the upstream is happening. Super. That file should be okay. Great. So now we have that send logic. Right here. So send setup connection to. Now. Okay, so now we receive the setup connection successor error back right there. And we want to like take a look at what's inside. So let's look at the message type. That's going to be incoming dot get header dot unwrap dot message type. Let me check what's going on with our errors down here too, so I don't get too ahead of ourselves. Oh, the new text isn't there. There we go. Oh, I need to import. Sync arc. And cool. So now the only thing that's complaining is that we're not returning a result, but we haven't finished the function yet, so that's fine. So let's look at the get header function. All it does is get the message header, but it'll be good to see kind of where that's coming from. So right here, we have the get header. Right here, so it's just returning our header. And if we see header is a struct that has the extension type, the message type, and the message length, these are just defined in the protocol. I forget exactly what they mean. And then we have we want to get the payload. So let payload, which will have our setup connection success, incoming dot payload. And then now we want to, okay, we need to initialize our downstream selector that we don't use. And that's going to be a proxy downstream mining selector. We're just going to say new. In the correct implementation, we should be passing in our downstream. And now we create a self that's wrapped in an arc mutex. Arc mutex. Oops. We have our connection. And our downstream selector is downstream selector. And I bet it's going to complain because the connection, I don't think I passed in as mutable. I guess that's fine. Okay, so now we define ourself here. And the last thing we need to do is handle the incoming setup connection or setup connection success or error. So we've received it and now we need to handle it. So we use parse upstream common messages for that. And there's a function in that's called handle message common. Let me. So that's in handlers common. Right. So that's going to take our self. We got to clone it. It's going to take that message type. It's going to take the payload. And then we are not doing any special, we're not relying on the Stratum V2 libraries to do our routing because we're doing the Stratum V1 proxy. So we are doing all of our routing for ourselves. Unwrap that. Okay, I wonder, that's not find common, that's in routing logic. So, and we can take a look at that. Right, so otherwise, we're specifying none. Otherwise, it would use the SV2 proxy logic. What's it complaining about now? Let me just pass back the final result. So then finally, we return self. So, and then we get that in our new function here. And we can just pass that right back. All right, let's see what errors we have. Make sure I did the right messages here. So parse upstream common messages, handle messages, common routing legend. Okay. That is one thing we need to do. Trait parse upstream comm messages is not implemented for upstream. Okay, so we need to implement that trait. So, okay, so that finishes like the setup connection logic. Okay, it was a lot. So now it's complaining about not having this implemented. So I believe we already have that. Parse upstream mining messages. I think it should be in selectors or common. Yeah, so let's look at that again. So we need to implement these functions. We're going to leave this one as is. That's fine. And we are going to basically mark all these as to do. And we're not going to do them during the demo. Okay, let me see. Simple. Okay, no routing for upstream. Okay, actually, we do need to implement these. But I need to actually change these results. I want to use something called send to common. Which is in roles logic handlers common. So we're going to implement send to send to common. Let's look at send to real quick. So with the type of these common messages, which I think we've looked at already, just the setup connection messages. I don't know why it's not coming up. Oh, it's an enum. So right here. So this is going to get called on to handle the setup connection success function in return. So we want to do handle setup connection success. Don't pass anything here, and that's fine. Got to pass this in the common messages. Setup connection error, setup connection success. So we have that available to us. We've defined send to common, and then our error is going to be from roles logic SV2 error error. So I actually want to do that for each one. So we're basically just implementing this trait to handle what happens on setup connection error. Just basically accept the message. We're not doing channel endpoints changed. So I think I can just actually, I'll just import it. It's going to be roles, common messages. Okay, and then no routing. So it's going to be okay. So that's in the routing logic. because again, we're handling all the routing. Okay, that should compile. Great. That compiles. So we've now successfully implemented that initial setup connection, and it works because we've implemented all of the traits that it expects. So where were we before? How come it says connection is never read? Oh, that's fine. Let's go back to the translator. Okay. Great. We've implemented upstream new. Now let's listen for the downstream to come online. So let downstream listener equal to TCP listener, which I need to implement. I think it's use async net TCP listener. Yeah. We're going to bind to that listen address. It's defined in the upstream. Actually, it's defined either in main or upstream, which is a minor address. Okay, so that looks good. And we're going to get the downstream incoming from the downstream listener. And while let some stream downstream listener dot incoming, or sorry, dot next. So to get the next message, it's incoming. I'm going to wait on that next message, and we are going to create our downstream struct here. So do a print line, proxy server, accepting connections from stream dot. Isn't there like a peer added? Yeah. It's weird it's not popping up. That makes me feel like I did something wrong. What's wrong here? Bind, downstream listener bind, wait and wrap, downstream listener incoming, forward stream, downstream listener next, that'll wait. Did I do the right listener? Oh, I think I also need to do this. Prelude. And we're going to need task eventually. Weird. What's going on? Something wrong with my import statement. Async. Exists for async, but its trait bounds were not satisfied. I don't know why that's the case. I'm missing an import somewhere.
What traits does a TCP listener have? Like, does a TCP listener have like traits it listens for or something, or you have to like specify for it?
That would just be in the async docs. I think there's something that I did wrong, but we can look at what the TCP listener imports or traits are. I don't know, nothing crazy. There you go. Just like send, sync, stuff like that. Stuff that I gloss over when I'm trying to learn about it. Okay. Let me see.
So like, sorry,
here.
so when you go down to like the next thing, like when you're calling next on it, what is next supposed to be doing then? Is there a reason you can't just call like delete the next and just call await on it directly?
I don't think it would get the next message. There's like, what's with that?
What methods does it have on it? Oh, it does exist, but the trait bounds were not satisfied.
It makes me feel like I'm missing it some weird import. I'm like referencing my other implementation to try to figure it out.
Yeah, it makes sense. Okay.
Incoming, bind, create, listen, await, down on wrap, downstream listener incoming. Some stream was downstream listener dot next. And then that's bizarre. Net. Let me just finish implementing this part, and then we'll figure out what's wrong there. So we are receiving from that. So let server, now we, I don't really like what's called server, whatever. Now we do our downstream. So we pass in our stream. We pass in our sender for downstream. We got to clone it. And then we pass in our receiver for downstream. Do that. And then we're going to put that in an arc mutex new server. All right, so we'll deal with this thing later. And let's implement new on our downstream. Okay. Okay, so we are going to pass back, well, let's do our inputs first. So we have that stream. It's going to be the TCP stream, and we're going to need that from use. I got to move the Zoom thing. Use async standard, right? Yeah, net TCP stream. And then we pass in our sender upstream, which is going to be that sender JSON RCP RPC message, and then our receiver upstream, which will be our receiver JSON RPC message.
Okay,
and then we need
JSON RPC because it's a V1 thing, right? You can't use the encrypted protocols between the downstream because it's still on V1. Okay, cool. That makes sense.
Yeah, and that like goes back to as well why we chose no routing in the SV2, because if we would have chose do routing, then the Stratum library will think we have a SV2 mining proxy, and we don't. We have this weird mixture. Yeah.
Good mix. Cool. Okay. Makes sense. Yeah. But I was like, why are you doing like the noise protocol to upstream, but not to downstream? It's because downstream doesn't know about the noise protocol. That's a V2 thing. Okay. Cool.
Which is why you want to use a translator proxy. So if you have SV1 firmware, you can get those encryption benefits. Okay, so let's import this. We're going to need all this. And this, great. Still don't know what's going on with this. Just
Cody put a suggestion in the chat. It says Stack Overflow says import the 2 missing traits stream and stream ext to bring them in scope for TCP listener. Where would that import it in the async STD?
Yeah, so just comma there and then stream. Lowercase stream, and then like the crab eyes, right? And then open brackets, close brackets, and stream, ext, and stream inside of there.
In capital, yeah.
Thank you. And what was the other one?
And stream. Yeah. So in the error, it says it's saying that it doesn't. There's no pulling them in.
That's weird.
It's so weird. Something's weird.
Something is weird. All right. Well, thank you for the suggestions. I love suggestions. Let me implement, we got to do the mutex real quick. So we are going to want, you just get this in here. Utils, mutex. It's like the only Stratum V2 thing we need in the downstream, and then also arc. Let's do that here. Okay, cool. So back to the downstream. If anyone else has any ideas on how to fix that, next, keep those suggestions coming. So back in the downstream. Okay, so we passed those in. Someone is requesting remote control of my screen. Is that you, Lisa?
That is not me.
Okay, I'm gonna decline then. I figured it wasn't. Okay, so now we're gonna return a arc mutex of ourself. Okay, I gotta include those over here. Okay. And then now we need to do a couple things. We need to define the socket reader and the socket writer that will communicate with the SV1 mine client. And then we need to define a sender outgoing and sender and receiver outgoing when we need to pass messages to be sent through that socket when we are handling SV1 messages that are not passed to the Stratum V1 or Stratum V2 layer. That will make sense as we move on. First, let's get our stream inside of an arc. So stream, arc, new stream, read and write from SV1 and D client socket. So let socket reader, socket writer equals stream, gotta clone it, stream. Okay, then this will make more sense when we start to get messages going through. Bounded 10. And then let's do our connection, our downstream connection, right? Stream connection. Let's open that up for reference. So we have our sender outgoing, which we just defined, our receiver outgoing. We have our sender upstream, which we passed in, and a receiver upstream. Great. Now let's make our new, call it just downstream. Equals arc new mutex new downstream connection. Yeah. All right, I'm missing one of those. There we go. Okay. I misspelled that. Okay, that looks good. Just going to throw this down here so we stop getting that return error. And then we need to do two things. We need to spawn a task to read from the socket, and then we need to spawn a task to send to the translator. So let's do the task for the socket because that makes the most sense right now. So spawn and then async. Yeah. Oh. Someone keeps requesting control my screen and it keeps like moving my. Can you disable that?
Yeah, I can try 1 sec.
Oh, someone said when the compiler tells you that a type does not implement a trait, but in the documentation you see it does, this means you have 2 different versions of the crate that defines the trait in your project. Maybe check dependencies or which version of async you're running. Okay, I'll check that after this task spawn. Thank you. Async.
Yeah, while we're doing that, can we take a couple, just a couple minutes to like kind of cover some of the sort of higher level of what's going on? So
Yes.
like a lot of this is the networking aspect for it, and so like the handshakes is that I think kind of like just like a good framework for understanding this is that handshakes are always like a 3-step handshake where it's like they call them like 3-way handshakes for this one. So if anyone's confused by this, is that like there's the initiator of like the person reaching out, and that's like the first part of the handshake, and then there's the response, and that's like the second part of the handshake. So it's like, hey, I have information for you. That person says, okay, send me the information, and then you actually send the information. And so like for if I'm reading this correctly, is that for Stratum V2 is like based off of the response part of that is that you're going to send different versions of the information based off of like what the second part of the handshake is, right? Like if you guys know for like how SegWit becomes backwards compatible, like it's taking advantage of that 3-way handshake part where if when I announce that I have new transactions to another node, I say, hey, I have new transactions for you. And that node will either respond back, send me the transactions, in which case I only send the transactions, or it will reply back, hey, send me the transactions and the associated witness data, in which case I know that it's a SegWit node. And so I'll send both the transactions and the witness data. And so as I'm kind of looking at this, it looks like Stratum V2 is doing something similar, is that like as a mining machine, I reach out, and based off of the way that I reach out and like based off the response, like the mining pool knows whether or not I'm running Stratum or Stratum V2. Is that correct?
Yeah,
Or,
spot on.
okay.
Okay, yeah, I hope this isn't too network heavy for everybody. Okay. We're almost getting, I mean, it's hard to get around like the network stuff because I was thinking about like implementing some of the channels first, but then I'm like, okay, well, we're not gonna know what those channels are. So this is the best I could do. So we're gonna get those messages from the socket. Messages equals buff reader, which we need to implement or import new and new and someone keeps like requesting control and it like removes my mouse and I can't.
Yeah, I tried
typing
turning it
without-
off so that the only person who can start screen sharing is the host. So
Yeah.
only
Does
the
it say
host.
who's
can-
requesting?
It was, but I wasn't paying attention, and now it says no, nobody is.
Hmm.
All right. Well, just next time it pops up, just tell me who it is, and then I can drop them.
This guy.
Oh, we can't see any of your participant stuff.
Oh, Thomas Fairchild.
Okay.
Booted.
Cool.
Great, thank you. All right, where was I? And star Andre Kashin, ANDREI.
Gone.
Thank you. Socket reader dot lines, and then we're gonna do wallet. Jeff Walker is now requesting it.
Oh, wait a second. I know Jeff. So why is he doing that?
I don't know.
Yeah, I don't think it's Jeff. Okay, I don't know what's going on here.
All right.
What is going
I don't
on?
know. Should we just?
Um,
Yeah. I mean, what we could do is we could just boot everybody and keep the recording and put that up, put that back on.
It's up to
Shall we do that?
Lisa.
I mean, yeah, I'm okay with that if that's like,
Yeah. Cool.
sorry,
All
Jen.
right. See you guys. We will
All right,
post the recording
guys.
later. Bye, guys.
Rough. It's cold there.
Yeah. Yeah.
Sorry, I'm working on shutting it down. Sorry, we've had people jump in before and we've always booted them, so it is a little like whatever. But this is the first time we've had, I don't know.
Yeah, it just keeps popping up from like a bunch of different
Yep.
people. So I think there's like
All
some
good.
bug in Zoom. Yeah. All right.
All right.
Okay, so let's get some
Just us.
messages from the socket. We'll let some incoming message dot next dot await. Let incoming was incoming dot unwrap. And then let's say, okay, like downstream receive SV1. Okay, and actually this is not going to work. I'm going to use incoming in a second. So then we want to handle this message, right? Because like it's not a one-to-one message between Stratum V1 and Stratum V2. So we're going to define a new function, handle message SV1. And it's going to take ourself. We have to clone it. And then it's going to take that incoming message, unwrap, and we have to await it. So down here, we're going to do async fn handle message SV1. And that yeah, 1 second. I'm gonna call it actually handle incoming SV1, and then there we go. So we have self, that's going to be an arc mutex self, and then we have message SV1, and that is a JSON RPC message. So first thing we want to do is we want to get access to that message and look at what it is. So we're going to do let response equals, well, first we're going to actually define a function here, and it's going to be handle message. Oh wait, actually handle message is implemented in a trait that we're going to implement in a second. So let's do response equals self dot save block. This is a custom function that FI3 implemented on the custom mutex. It's really handy. Handle message SV1 dot unwrap. So let's see what we get there. All right. So get that in our implementation. I'm not really sure. Here we go. And then so the handle message happens in the trait called is server. So let me do grep trait is server, and that is in the V1 lib trait is server. So we want to implement this for our downstream. And so like the way I started doing this was there is an example of an SV1 client and server. And I was looking at that and I was like, okay, they have this server struct and they impl is server on there. And this handles all of the SV1 messages. And so it's like, okay, like I want to implement that on my downstream. So the first thing I need to do is I need to make sure my downstream has all these messages, has all these member fields. So I copied all these member fields except for the connection because I already have my connection.
Mm-hmm.
And I pasted them in my downstream. And so then I went up here and I need to, I'm just going to copy all of the V1 imports and then keep what applies to me. And then I'm going to save that and see what errors I get, because I'm going to get a lot of errors. Okay, so it's missing. So our downstream is missing all of those things now. So I'm like, okay, how did server do that? So server just hard coded all this. So I'm going to copy what they did, paste that there. So now our downstream, will be compatible with that is server implementation. Okay, and it's complaining, it's like, hey, you need to implement these functions. So let's get rid of these extra things we don't need. I know we don't need that. I think we might end up needing these other things though. So that's so annoying. It's not working. Let's copy those messages or copy those functions over. So impl is server. So handle configure, that's going to handle the mining.configure message. Handle.subscribe, authorize, all that. So we're going to copy this in here and then it's going to complain because we're going to be missing a few more functions. So it's going to say, okay, it doesn't have these like new extra nonce functions here. So I'm like, okay, like what is that? And they, in this example, they just have these hard coded. So I'm just going to copy this and paste it. I'll paste it at the bottom. And so now we have everything we need to have a functioning downstream act as a server to an SV1 miner. But we're going to have like some modifications because we don't want to, what this is doing is like these will just like pass back let's go in and look at the handle message. So is server. Let's look at that trait right here. So handle message is taking in a JSON RPC message. It's saying like, okay, is this a response? If it is a response, it's going to error because the Stratum V1 server doesn't accept JSON responses. If it's not a response, it's a request, then it's going to handle the request. And the way it handles the request is right here. It says like, okay, if it's an authorized, then we're going to send back this authorized.respond. If it's a configure, we're going to send back this configure.respond, which is great in some cases, but like not in all my cases. So I'm actually going to want to implement my own handle request. So, well, also just cut me off if I know I only have like 12 minutes. I can keep going for a long time. So you just tell me when it's over. So up here, I have this handle message function. So let me look at my reference. Oh, the handle message I'm going to keep. Okay, so I do want to get back this response. But what I want to implement is a handle request. So I'm just going to copy all this, which is the trait implementation. I'm going to paste it right here. And I'm going to go in and I'm basically just going to put to-dos here. And once we get this running, it will error when it receives a Stratum V1 message, and it'll tell me where it's erroring, and then I know to implement that message. Okay. Oh, what's it complaining about now? Oh, I need to implement methods. So methods, great. All right, how many errors do I have? We've got to fix that next. Oh, in Translator, we need to import downstream. And then, okay, not found in scope. Hang on. Okay, so this, I need this self, I need to create, which is just going to be a clone of that downstream. Okay, and implement task. Yeah, that works. Oh, and buff reader, which is buff reader. Like that. Hmm. 66. Wait. No method found in. Okay. I need to serialize this as JSON. Yeah. So let incoming equals do result. So we have this string, and I want to convert it into a JSON RPC message. Nothing there. So we're just going to use. Sorry, 1 second. Already wants to come up. Okay. Okay, so where was I? There we go. Message, nothing, and then let me just do Saturday JSON like from stir and do and incoming and wrap. Let's see what that gives me. Maybe I don't need that there. Okay. Okay, so now we should be able to do that. There we go. Still so weird about the async. Let's just like go look at that for a second. And let me pull up my reference implementation. All right. What am I doing differently here? Oh, duh. I have this as listener and this needs to be incoming. There we go. Great. Okay. Do I have enough to actually try to spin this up? Let's try to actually see what happens when we try to connect to a pool. So we're gonna have cargo run -p pool. And then let's see if this even will run.
So the bottom pane there is the poll running. The middle pane is your translator. And then the
Yeah.
top one is the mining device. So the mining device is going to talk to the translator, who's going to talk to the upstream pool for it.
Yeah.
Cool.
So yeah, this is the SV2 pool, this is our translator, and this is the SV1 mining device. So, all right. So we are accepting connections here. This is
Hey, you
not
got the panic. You hit it to do, right?
I hope so.
That's what I'm guessing the not yet implemented yet is a to do, right? So
Do you see do you see? Okay, yeah,
in
you
the
see that
translator,
here.
yeah,
Yes, perfect, great. And so, okay, look at this. We have the downstream receives the mining.configure from the from the downstream miner. We should have hit some stuff with the upstream that we haven't yet, which is like kind of annoying. So I think we need to go back to the upstream and do a few more things. But let's so yeah, there's the to do, right? That you just mentioned, Lisa. Downstream. So it is on line 99 and it's going to be that configure message right here.
Cool.
So great. So the downstream is looking beautiful. I'm going to implement is mining downstream because I know we're going to need it. I'm going to get rid of this. Do rip grab trait is mining downstream. Okay, that's in common properties.
Rachel, I had a quick question for you. You're using
Yeah.
Tmux for your windows and stuff. What are you using for the are you using the Emacs for the code, or what's your
NVim.
oh, okay. Then
Yeah, which is like a lot of plugins. And like
yeah, you
the
have a lot of plugins turned on. That's cool.
yeah, and like the Rust Analyzer LSP, which I really like.
It makes it look like a proper like ID. I mean, it is a proper ID that it like looks like.
It's really nice. I love like the fuzzy search too. Like, I don't know,
Yeah.
it's just really nice.
Cool.
Also, I know we're almost at time, so I don't know if you want to cut me off or if you just want me to keep going.
Yeah, let's go ahead and just do a wrap up. We've got like a few minutes and stuff. So what would be like your next steps here? Like, so
Okay, so the next steps, let's I'll show you what the end result is, which we started with, right? So we started here. So if we were to continue implementing the upstream, the first thing we should get is the upstream connected. So we didn't get that yet. And then we would get the setup connection stuff. And then you see, so upstream receive parse. Let me just open up the code so we can actually see it.
And just kind of like big picture, like the big impacts for Stratum V2 here is that the reason why this is like such gonna be like so important is because like on the mining side, it's like all that hardware is patented. Like that's not something that we can play with, right? But like the connection layer that you're going through here, this is something that like is screaming for optimization in terms of like adding the noise encryption, like all that kind of stuff. And this is something anybody can use, right?
Exactly. Yeah, without having to change your firmware. Okay, so here we just implemented that, right? We got our downstream going. And then this spawns a task and waits for listening for incoming messages from the downstream. Right here, we get our message. And then we parse, here's where we would parse the SV1 to SV2. So we have this function, it's a to-do, SV1 to SV2 here. And then let's see, we have this task to listen for the SV2 upstream right here. So it would receive from the upstream. So if we look at the upstream again, this is what the complete upstream looks like. So we have this connected, we have the setup connection, and then we have a parse incoming. which is called in the setup connection. And so the parse incoming, so the reason why we didn't get the connection earlier is because we hadn't implemented the parse incoming function. And so what that does, we have the receiver from the upstream, we get the message in the payload, and then we handle the mining message. So FN handle message. Okay, that's implemented in a trait, probably the is upstream trait. And so then we respond, we get the next message and respond to it. And it's going to be like a pool mining message. So a set new prep hash or something, and we're going to put in either frame, and then we're going to send it to the downstream, right? And so our downstream is our translator. We receive right here, we receive from the upstream, and then we parse the SV2 to SV1 in this to do function. And it just continues from there. The miner is sending submits. And so we get the submits from the receiver downstream and translates them to a submit new extended job and forward them up to the upstream. That's it.
Cool. Cool stuff.
Thank you so much.
Yeah, thanks for showing us.
This is
awesome.
Yeah, I know it's a little dry, so.
What are you talking about? This is the most exciting stuff. This is
Okay.
You're like the first person who's actually like tried to do live coding on our Base58 encoding. No, that's not true.
You told me it was a 2-hour live coding session. I get prepared for 2 hours of live
well,
coding,
that's what we tell everybody, and then they have.
For
like
the
10 minutes
record,
to
I've
code.
told everyone the same thing. So like, yeah.
All right.
No, this is perfect. This is great. And like, honestly, like the thing is like, we're trying to expose people to a bunch of different stuff. This is like perfect. This is like protocol development for miners and like, how does network connection stuff working? And while you were talking, I was like explaining everything that you're doing in like the chat and stuff. So
okay,
like,
good. I appreciated it when you guys jumped in and you explained the handshake stuff very well. Cody, I really appreciated all that.
Yeah.
All right.
I love this stuff. This is like, because like
I mean,
all the
me too.
Bitcoin developers, like none of the Bitcoin developers like work on the mining thing. Like I was at SF BitDevs and Matt Corallo when I was asking about Stratum V2 because I knew you were coming on, and he was just like, are you interested in working on it? Like I can't find anybody to work on this thing.
We need people. It's like it's just a couple people right now. So hop in.
yeah.
Yeah. So the handoffs for this are that for. So let me share my screen. I'll go through all the links for everything. You are Rachel at _RRYBAR.
Yeah, that's me.
YK. Yep. Then Stratum V2 is the specification is a Google Doc, which I was surprised by.
So I took I took that and I put it on the GitHub because I think it's bad optics to have one company control that on their website. And I think they would agree. So I'm trying to get everyone to move over to the shared GitHub, which has a couple more updates on the noise protocol, actually. So it's and then SV2, go to the Stratum mining organization at the top. Top left. So the spec is SV2 spec right there.
Okay, gotcha.
3 stars. What are we gonna fix this? Hang on.
I know. Yeah.
Sure. Let me start.
Thank you. And then you know where the code is, and then I can direct you to the translator branch if you want that has a more complete. I'm still working on it. Like it's going to be a little while, but a couple weeks. I'm hoping for like a first working iteration.
Dude, that's so cool. That's so cool.
Whoa, this is the biggest README. It's awesome.
Thank you. I worked really hard on transferring it over to Markdown. I feel like I worked too hard on that. There was probably like a easier way to do it.
It looks awesome. I don't know what you're talking about. Wait, why is your name not on the author list? This is my only question.
I didn't author it.
Yeah, but this is like, oh, okay, that's fair.
I didn't author it. Yeah.
And this has been around for like a while, right? Like Stratum V2 is.
Oh, so the protocol's been around for a while. You're just working on implementing it.
Yeah.
Because right now it's just Brains that uses it, right? And the idea is to have everybody implement this thing.
Yeah, and they
then-
only implement a small subset, right? They only implement the firmware side, and they only have standard channels because you can only use standard channels if you don't use a proxy. And I'm not sure what kind of encryption they implement right now. I know there must be some, but I don't know
Yeah.
how complete that is.
This is
And it's
cool.
only for a few miners. Yeah.
But so eventually this will just be that anybody who wants to set up a mine just implements this. And then if you're running like a farm or whatever, then you don't have to do any changes. Like you can just get your normal Bitmain miners and then you're just intercepting, because I thought that was so cool that this is like the reason why this is like so important is because like we can't touch like the hardware, right?
Yeah.
But like what's very easy to do is to intercept the communications and like do that correctly, right?
Yeah, that's exactly right.
Okay. Yeah.
Yeah, that's everything. Thank you so much.
Cool.
This is awesome. Thank you, Rachel.
Yeah.
Yeah, I'll talk to you guys later. Bye.
Bye, Tom. Yeah.